Hey everyone, Mr. Voikin here, and we're going to take a look at Unit 5, Lesson 5, Multiplication of Polynomials, Part 2. It's basically the same, just looks like we're going to be dealing with a binomial and multiplying that to a trinomial. So in this example, it says there's a rectangle, and it has a length of 5x plus 2. So basically we have a rectangle right here, and it has a length of 5x plus 2. And it says the width is x squared plus 2x plus 1. Okay, and determine the area of the rectangle in centimeters squared. So each of these has the units of centimeters. And don't forget that the units are very important. So there's a huge difference between centimeters or inches, feet, meters, miles, kilometers, etc. As well as when you're taking a linear measurement, it would be centimeters. An area calculation would yield centimeters squared, and a volume calculation would yield an answer with, say, centimeters cubed. Okay, so we want to figure out the area of this rectangle, and we know that area equals length times the width. That's a very bad W. That looks better. Okay, so basically all we're going to be doing is multiplying these two together. See if I can take this thing and move it down a little bit. Okay, so let's just put these together and expand it out using the distributive properties. So we got 5x plus 2 times x squared plus 2x plus 1. Okay, and basically what I would start off with is taking that first term in the binomial, multiplying it by the first term, then the second term, and finally the third term. Then I would take the second term of the binomial, multiply it by the first term, the second term, and then the third term of the trinomial. Okay, so 5x times x squared is going to be 5x and cubed. So that one is done. The second one, 5x times 2x is going to be a positive 10. X squared, and 5x times 1 is going to be a positive 5x. Move on to the second term in the binomial. We have 2 times x squared, which is positive 2x squared. Next we have 2 times 2x, which is plus or positive 4x. And finally we have 2 times 1, which is going to be 2. Now all we need to do is gather like terms and put it in a descending order, starting with the highest degree, which in this case would be 3. So if I look at any terms with a degree of 3, there's only 1, so we have 5x cubed. Okay, that is done. Now let's move on to our degree 2 terms. So I got x squared. Oops. I have 1 right there, a positive 10x squared and a positive 2x squared, giving us a total of plus 12x squareds, and those are both done. Move on to degree 1 terms. We've got a positive 5x and a positive 4x, giving us a total of 9x. And finally, we move on to our last one, which is the constants, and we've got a positive 2 plus 2, and that would be our final answer right there, except we don't want to forget our units, which is going to be centimeters squared. Okay, this second example is pretty much identical to the first example. The only thing is we're not actually calculating area, we're just taking a binomial and multiplying it to a trinomial. Just be careful with the exponents and the negative integers. We would do the same thing, take the first term, and we're going to multiply it by term 1, term 2, and term 3 in that trinomial. So x squared times 2x cubed is going to be 2x with the power of 5. X squared times x is going to be a positive x cubed. And x squared times negative 5 is going to be a negative 5x squared. First term is done, so we'll move on to the second term. I'm multiplying with a negative 4 times a positive 2x cubed is going to give me a negative 8x cubed. The negative 4 times the x is going to be a negative 4x. And finally, negative 4 times negative 5 is a positive 20. Okay, and just like we did before, we want to now take a look at our terms that we have. So we have 1, 2, 3, 4, 5, 6 separate terms. I now need to combine like terms and put them in the degree of descending order. So I'll start with the highest degree, which is 5, and I have 1 right there, which is 2x squared to the power of 5, and there's nothing anywhere else, so I'll put that right there. That one's done. The next highest degree looks like it's going to be 3, so we'll say we got a positive 1x cubed and a negative 8x cubed. And when I combine those together, I'm going to have negative 7x cubes. So notice that we've skipped the 4. There isn't a term with a degree of 4 in this case. Now, is there a 2? Yes, there is. So we're going to move on to that one. So I have a negative 5x squared, and there are no other terms with the degree 2. So that will get placed right there. And that one is done. And now let's move on to our degree 1, which are the x to the power of 1. I got only 1, negative 4x. And finally, we have our positive 20. And that would be the final answer. Okay, so it looks like we have another question where we need to calculate, in this case, the volume. So volume of a rectangular prism is going to be the length, do that again, the length times the width times the height. So we know that basically two binomials being multiplied together are going to produce a trinomial, and then we'll be back to what we're moving on to in this unit, which is a binomial times a trinomial. And it doesn't matter which two you multiply together first, and also make note of the units, which are in this case are all centimeters. And it's important to check that they're all centimeters, because sometimes questions might tell you that this one's in millimeters or meters, and they're expecting you to do some unit conversion first. Okay, but in this case, they're all the same units, and I'm going to be solving for volume. And even if I want to, to make sure I don't forget when I'm doing the test, I know my units when I'm finished should be centimeters cubed. So, feel free to make yourself a note like that so you don't forget to do that on a test and start losing important marks. Okay, so let's multiply the length times the width right now. So I've got x, I'm going to write that in gray, x plus 2, and I'm going to multiply that to x plus 1. Okay, so first of all, I'm going to deal with those two binomials just by expanding this out. So x times x is x squared, x times 1 is positive x, 2 times x is going to be plus 2x, and 2 times 1 is going to be a positive 2. I have like terms right here in the middle, so I'm going to combine those together, and our final answer for these two binomials being multiplied together is going to be x squared plus 3x plus 2, and we want to put that in brackets. And now we want to multiply that to the height, which is x plus 5. So I prefer to put the binomial in front and the trinomial at the back, but it doesn't really make a difference. So in this case, I've got an x plus 5 that I'm going to be multiplying to that trinomial. So let's deal first with the x, and you can see I have x times x squared, which is going to be x cubed. X times 3x is going to be positive 3x squared. X times 2 is going to be positive 2x. Now let's move on to the second term of the binomial, the 5, and multiply it in succession to each of the terms in the trinomial. So I have 5 times x squared, which is a positive 5x squared. 5 times 3x is a positive 15x. And 5 times 2, they're both positive, so I have a positive 10. Time to gather like terms. Start with our highest degree, which is going to be 3. So I have 1x cubed. You're done. Let's move on to our squareds. I got a positive 3x squared and a positive 5x squared, giving us a total of positive 8x squared. Move on to degree 1. I have a plus 2x and a plus 15x, giving us a total of positive 17x. And finally, moving on to our constant, a lonely little 10 down there by himself, plus 10. And that will be our final answer in descending order. Yes or no? No. Why? Well, don't forget that. Centimeters cubed. Centimeters cubed. Now, final answer. Okay, and if on the test they asked you to produce a word response, you would just say that the volume of the rectangular prism is that. Okay, so this is the last example in this lesson, and really this one is just, again, just getting a little bit more complex and reinforcing the subtraction of the left side and right side, okay? And don't forget the rule where we're going to change this to an addition and then change the signs of all the terms in the end bracket. But what I want to do first, before I subtract, is I want to expand out the right side and I want to expand the left side as well. So right now, let's deal with the left side. So the first thing I'm going to do is I'm going to multiply these two terms right here, the 4 times this binomial. Okay, so I get a 4. I'm going to do this in gray again. A 4 times an a minus 4 is going to give us 4a minus 16. And I want to put that in brackets, and now I'll multiply it to that trinomial that is also on the left side of this expression. So 4a times a squared is going to give us 4a cubed. And 4a times negative 3a is going to be a negative 12a squared. 4a times negative 6 is going to be a negative 24a. Move on to the second term, which is negative 16. And don't forget, it is a negative 16, not a positive 16. So negative 16 times a squared is going to be negative 16a squared. Negative 16 times negative 3 is a positive 48. And don't forget the a. And negative 16 times 6 is going to be a 96. And they're both negative in this case, so it'll be a positive 96. Okay, now that is the left side right here sort of done. Okay, and from that we're going to subtract the right side. Okay, so Before I move on to the right side, I just want to combine like terms and put this left side in a simplified and organized order, descending order. So what do we have? The cubes, degree 3, I got 4a cubed. The squares, I've got a negative 12 and a negative 16, giving us a negative 28a squared. The a's, I've got a negative 24 and a positive 48, giving us a positive 24a. And finally, I have my 96 right there. And we'll put that all in a bracket. We'll move it over just a little bit. And don't forget, we are going to subtract whatever we get on the right side here. So let's deal with the right side, which is going to be 4a minus 3 times the 4a plus 3. Okay, so you can see right here that we can expand this out quite simply using the shortcut rules, or we can expand the thing out completely and then combine like terms. Okay, so because we have a difference of squares here, we know that the middle term in this process will be opposite and cancel each other out. So all we have to do is multiply the first two together and then the last two together, and that will give us a 16a squared minus 9. And that's going to go into brackets right here, and basically that is going to go up to there. Okay, so now remember the rule, we're going to be subtracting right here, so I need to change that to addition. And then inside the second bracket that we're subtracting from the first polynomial, the positive 16 will change to a negative 16, and the negative 9 will change to a positive 9. So I'll just make those changes really quickly here. And now that we have an addition of the two polynomials, all I have to do is combine the like terms. So here we go. Let's start off with our highest degree, which looks like it's going to be a 3. So we have a 4a cubed. Let's go to our degree 2. What do we have? We've got a negative 28, and we got a negative 16a squared. Combined, we're going to have negative 44a squared, and all three of those are done. Let's move on to our terms that have a degree of 1. So we got a 24a, and that is it. So plus 24a. And finally, when we look at our last one, which are the constants, I've got a 96 and a 9, giving me a total of positive 105, and that will be our final answer. Okay, well, here is your at-home assignment that you are to complete and bring into me as your homework. Question number 1 is pretty straightforward. Just be careful with the positive and negative integers. Question 2, I've just put some arrows to some important parts to make sure you don't miss them. Question 3, we're going to calculate the volume of that cube. And don't forget the units again, which I've put in orange there for you. And when you arrive to class, we will work on questions on pages 301 through 303.